Hello, my name is Budu Kritish Kamal. My dissertation title is a chatbot for helping people to cope with depression. There are some problems associated with the traditional way of mental health care service. Firstly, mental health treatment is expensive and does not assure the full treatment. According to the World Health Organization, over half of the world population does not have access to even basic healthcare service. So mental health treatment in traditional means won't be affordable for most people. Secondly, fear of being judged due to social stigma associated with mental health. Moreover, there is a lack of assistance and availability of mental health care. The therapist can't help everyone. For example, if it is late at night or in odd hours and the patient is not feeling well, a therapist won't be available at that moment. Lastly, people are uncomfortable to open up to a therapist. People prefer robots over therapists. A study done by Oracle shows that 68% of humans would choose robots over people to speak about depression. The aim of this project is to develop a conversational based, emotionally intelligent chatbot that can detect emotion through voice to help people deal with depression by providing empathic messages to them. The objectives of the project is to develop a chatbot to help ease stress by providing supportive text, make interaction possible with a chatbot using both text and audio messages. The chatbot will be able to respond by using pictures, GIFs, videos, text messages, and web links to make it more user-friendly. Detect emotion through the voice to predict depression level of the user. Display a daily mental health progress report to the user. The user can converse with the chatbot in either English or French language to reach a larger audience. Tools and technologies used for this project. Python was chosen as a programming language because it provides many inbuilt libraries. Floss has been selected as a web framework as it is a Lang framework with the ability to create design quickly. IDE, Visual Studio, and Colab was used for executing Python code and training the model. NLTK was also used, which is a toolkit for NLP and computer linguistics. Keras was used for developing and evaluating the deep learning model. TensorFlow was used for deep neural network prediction and training. librosa has been used, which is a powerful Python library developed for audio works and analysis. How the chatbot system works. Users access the web app, which make use of the Floss framework, then open up chatbot interface where all the messages are saved into the MySQL database. The user query is then compared with the trained chatbot model to get a response. The sentence classifier categorizes each user input as sentence into the dataset. The admin can keep on improving the dataset which are found in the JSON file. The chatbot framework consists of stop word removal, which are common English words to be removed, tokenization, which is a method for separating words or sentence into smaller parts, which is eventually called as a token, legmatization, which group together different types of words referred to as a legma. It combines multiple words into a single root. Accuracy threshold, an accuracy of 40% or above 40% allows the chatbot to reply, else a default reply will be sent, asking to clarify more. After all this, the model is then trained. Moving to the chatbot codes and implementation. These could represent how the chatbot was trained. These are all the libraries that has been imported. This part shows how the dataset for the chatbot has been imported. These code loop through the intent and the pattern to tokenize each word. The legmatization convert all characters into the lowercase and remove common English word. This part represents the creation of bagger word, and this part represents the creation of the train and the test list. Using Keras, the model was built, and the model was then trained, and an accuracy of 92% was obtained. The graph below shows the training and the validation accuracy of the chatbot. And this one shows the training and the validation loss of the chatbot model. The dataset used for the speech emotion recognition is RAWDES and a customized dataset. The RAWDES consists of 1,400 audio files, which was created by recording of professional actors. The customized dataset was created by me and my project partner with over 700 audio files. Both the dataset has the following emotion: neutral, happy, sad, and angry. Moving to the framework model of the speech emotion recognition, both datasets are combined and male frequency is used for the feature extraction. Male frequency spectrum coefficient depends on the fluctuation of the human ears, which is proportional to the log of the linear frequency of a sound. The dataset is split for the training and the testing. CNN model has been used for the training of the model. Then the CNN model is tested with the test data. The model is then saved. The model is connected to the FLOSS framework to be able to detect emotion from the user's voice. Moving on to the speech emotion recognition code implementation and demo. This file represents how the speech emotion recognition model was built. All the libraries needed was imported, like rebrowser. The next step was feature extraction, where the male frequency spectrum coefficient was used to help the model to distinguish between different emotions. X represents the spectrum with all its coordinates, while Y represents the emotion associated with it. The dataset was divided into training, 67% for training, 33% for testing. The convolutional neural network was then built. This represents the summary of the convolutional neural network, giving it total parameters of 87,000 parameters. While the model is compiled, then it is trained. An accuracy of 85% was obtained. Below shows a graph of the loss model of the speech emotion recognition, and this one the model accuracy, 85.47%. The demo of the project. I am considering a scenario where someone has no support. Along with that, I will test all the different types of speech emotion that the chatbot can detect. First, I will try to respond in a neutral voice emotion. Hi, not so great. Can you help me? The chatbot will reply with a friendly tone, and the speech emotion recognition has predicted it as neutral. This part below shows a total calculation for both the text and the speech in terms of neutral, not depressed, and depressed. Now coming up to the angry voice emotion. Yes, you are right. Things are never going to change. The chatbot will reply with a supportive text. The speech emotion has accurately predicted it as angry. Next is the sad emotion. I am never supported by anyone for my efforts and ideas. The chatbot response consists of image, and it has predicted the response accurately. The image makes the chatbot more user-friendly, and for the speech emotion recognition, it has predicted the voice accurately as sad. Lastly, I will try a happy voice emotion. Yes, please help me with it. So for the speech emotion, it has accurately predicted it as happy. Users can also command voicing the chatbot. For instance, play relaxation music. The chatbot send videos, make it more user friendly. And the video can play within the chatbot itself. Thanks a lot, I'm feeling much better. Users can also converse with a chatbot using French as a language. For instance, I will ask some general question in French. Quelles sont les causes de la maladie mentale? The speech-to-text function translates it accurately. The chatbot will also reply in terms of French language. I can also ask some common questions like Je suis pas en bonne santé. So the user can converse both in French and in English. Moving forward, the user can also keep track on their daily mood details. They can have their mood progress daily, and they are able to search their mood by day. Future work for this project is to use a larger dataset for voice, add a 3D animated avatar, catered more scenario, use AI for depressive sign through facial recognition. Below shows a result for both of the model. I am grateful to my supervisor for giving me the opportunity to work on this project. Thanks for your attention.